So let's talk at greater length or intricacy into significant figures and really start to get more into the nitty gritty. So just to review what we talked about earlier here, the number of significant figures is dependent on the tool that is doing the measurement. A measurement includes this idea of known digits, and an approximation. Digit, right? The approximation is always the last digit of the number. So if we had a measurement, say, of 85.2 centimeters, this value has 3 significant figures. We have 2 of those significant figures that are known, and then we have that last digit, which is the approximation. So all digits in this sense are significant. Step 2, or idea 2, would be the placement of the decimal point does not affect the number of significant figures. Since the measurement is still the measurement. So if we use our example above, 85.2 centimeters would be the same as 8.52 decimeters, which would be the same as 852 millimeters. These are all same measurement, right? We're just moving the decimal place around. Right? All have 3 significant figures. So we can move the decimal point around, shift from one unit to another, or shift from, one type of scientific notation to another. Because we could say 85.2 centimeters is the same as 852 times 10 to the minus 1 centimeters. Or we could say 8.52 times 10 to the first centimeters. Again, moving a decimal point around using scientific notation, but still the same thing goes. So we always have the same number of SigFigs based on that actual measurement. Zeros is the next topic within SigFigs, and these are the troublesome, these are the troublesome crew of the bunch. So there's a couple different rules within zeros. So if there is a decimal spot, then all zeros to the right side of the measurement count as significant. So if I had an example of 85.200, there are 5 significant figures here. But if I had a value of 49,000, there's only 2 significant figures. There's no decimal spot. While above, we do have a decimal. If I do one more example here of 56,100 decimal, this would still be 5 significant figures. We have the decimal spot. So the zeros to the right count. So 0 to the right side of the measurement count if there is that decimal spot. So those are certain zeros that do count. Zeros in the middle of a measurement always count. So if I have 56,015, there's 5 significant figures. So zeros in the middle always count. And lastly, C, zeros in the beginning or the left part of the measurement never count. So these are numbers or values that come, before. If I have 0.0856, this is only 3 significant figures. These zeros at the beginning do not count in terms of that measurement because we could just move the decimal spot around. So that's the deal with zeros. Zeros at the beginning never count. Zeros in the middle always count. And zeros at the end or the right of the number, well, you got to be really careful and keep an eye on that decimal spot. As far as expressing, very large values, or very small values, we use scientific notation. Or Greek prefixes. Though I think scientific notation is a little bit easier. So if you have 0. We have 0.00000000934. That's the same as 9.34 times 10 to the negative 8th grams. All of these are zeros to the left. And as a result of that, they don't count. Here we have our known digits. And the 4 is the approximation. So we started on the left with something that has 3 significant figures. And our number on the right also has 3 significant figures. I could also say that that is the same value as 93.4, or 934 I could also say that's the same as 934 micrograms as well, right? Again, still has that notion of 3 significant figures still. Or we can go the opposite direction in terms of a very large number. So let's say we have this very large volume of liters. We would tend to want to write it in terms of that idea of scientific notation as 5.3 times 10 to the 9th liters. All those zeros to the right don't count. Because there's no decimal. And so we have our known digit as well as the approximation. So just two significant figures. And so since we have 2 with the measurement, we would expect the same for, just using it in terms of scientific notation, or using the idea of Greek prefixes, which would be 5.3 gigaliters. So the measurement is the measurement, and the tool that's defining the measurement really sets the level of significant figures or the accuracy of the process.